Yes, good day everyone. Welcome to Mr. Samwealth MTH classroom. Continuation of the MTH 103 Unit 1 Vector. Now, formally we've been able to learn the definition of vectors and the difference between scalar quantities and vector quantities. Now, we are moving to vector representation, which is very important for us to understand. It is an important side of this course. Vector representation. A vector can be graphically represented by a drawn line. It can be graphically represented by a drawn line in which the length of the line is the magnitude. In which the length of the line is the magnitude and the direction of the line is indicated by an arrow edge. That is, the direction of the line shows the direction of the vector. Are you getting it right? Now, the vector quantity AB, we call this vector quantity AB, is mathematically written as vector quantity AB. This is the way we write it mathematically. Vector quantity AB is written this way mathematically, or written this way, vector quantity AB. That means we represent with a small letter A. Now, that's it. Now, the magnitude of the vector quantity is written as this modular bar sign with your bar, head bar. Now, this is called magnitude of the vector quantity AB. This is called magnitude of the vector quantity AB, or this way, magnitude of the vector quantity AB, or simply written as magnitude of the vector quantity AB in this way or in this way, in small letter A or in capital letter AB or in small letter A. That is it. Now, you have to note that vector quantity vector quantity BA represent the vector with the same magnitude of AB, or vector quantity AB. It represents the vector with the same magnitude but opposite sense of AB. That is it. Now, you have to understand that this means the opposite of AB. This BA means the opposite of AB. What do I mean? For example, you're given this vector quantity AB. Now, vector quantity AB here, this line represents the vector quantity AB, and the arrow edge shows the direction in which it goes. Now, the vector quantity AB is equals to vector quantity A, that will represent the small letter A. Now, let's come to this side. Sorry, so that we understand what I'm saying. Now, let's come to the down part side. This is what I was saying. Vector quantity AB equals to this vector quantity AB equals to A. Vector quantity A. Are you getting it? Now, same here. Vector quantity BA. Now, note this. Anywhere the direction is facing, that's where you start from. The direction is going this way. So you start from BA. This is vector quantity BA. It will be equals to minus vector quantity AB, because it's going to opposite direction of AB. That's why we have negative of AB. I believe you get that right, and that automatically will give us negative of vector quantity A. That is it. So we have to understand that part. Now let's quickly move to equal vector. Equal vector. I say two vectors are said to be equal. Two vectors are said to be equal only if they have the same. Now, I said two vectors are said to be equal only if they have the same magnitude and direction. The same magnitude and direction. Now, I said only if they have the same magnitude, that means the same magnitude and direction. That is when they are equal. What do I mean? For example, a vector quantity A has the magnitude of 2 centimeters, and another vector quantity B also has the magnitude of 2 centimeters. So we can now say vector quantity A equals to vector quantity B because they have the same magnitude and the same direction. Because they have the same magnitude and the same direction. Now, types of vectors. This types is very, very important and we have to pay attention to it. Types of vector. We have different types of vectors and some of it are the position vectors, the line vector, the free vector, the unit vector, the zero vector. I'm going to talk about that. Now, the position vector. This represents the position of a point in space relative to a predefined set of coordinates. Relative to a predefined set or coordinates. What do I mean? What can I take as a physical example? Fine. Good. I believe you understand. Or okay, let me use a key lock. For example, this is a key lock. It is fixed to this direction. When you turn it down, it's open, but when you release it, it goes back to its direction. It goes back to this direction. Go back to this direction. When you press it down, it's open. When you release, it goes back to the direction. Yes. This is a practical example of a fixed vector. A practical example of a fixed vector. Look at. I turn it down, I release, it go back. Are you getting it? So it is fixed. So we call it a position vector. A position vector rather. Now, turn it down, release, it go back to its position. It is fixed. So we call it a position vector. A position vector. Thank you. Now the other one is a line vector. Is a line vector. Fine. This is a type of vector that can shift or slide along its action. It can shift or slide along its action. It can shift or slide along its action. I'm trying to look for a practical example that I can use. Practical example that you can use. Okay, I can use a curtain as a practical example. I can use a curtain. You can shift the curtain this way. You can also shift it this way. It's a practical example of a line vector. Yeah. Now, another one is a free vector. A free vector is not restricted in any way. It is completely defined by its magnitude and direction and can be drawn as any one of a set of equal line, just like this. Are you getting it? So a position vector, a free vector rather, a free vector is not restricted. It is very free. It can be drawn or represented even by a line. Even by a line. It can be drawn or represented even by a line. That's what I mean. So I believe with this short one, we should be able to identify types of vector, how to represent our vector. When we say graphically representation of vector, the word graphical means drawing, like picture. So, and the graphical representation of vector is by drawing a line. So yes, by drawing a line. So I believe we've been able to get what we call opposite vector. Opposite vector, they have the same magnitude but different direction. The same magnitude but different direction. A is going toward the north, B is going toward the south. That is A towards the north, B towards the south, something like that. So we can call it opposite vector. That's it. But they have the same magnitude. If this one is 2 centimeters, the other one is 2 centimeters, but they are opposite vector. Now, equal vector, you have to know that they must have both the same. They must have the same magnitude and the same direction. If A is 1 centimeter, the other one too must be 1 centimeter. If A is going towards north, the other one too must be going towards the north. That is what we call equal vector. So if you can go through this video very well, I'm very sure you'll be able to get a lot of understanding before the next class. Thank you.